At precisely 1,000 revolutions per minute, the serpentine belt of an engine physically strips electrons from their atomic orbits. It happens silently, hidden behind a firewall of steel and plastic. Yet, the moment a mechanic loosens a single mounting bolt and drops that heavy, grease-stained block of aluminum into a plastic bin, a universal illusion takes hold. You believe the machine is dead. It is not. You have merely severed its connection to a single, highly specific ecosystem. Every single year, millions of these units are abandoned in landfills or traded away for loose change. This is a profound violation of structural design. What you casually dismiss as a dead alternator is, in reality, one of the most resilient, brilliantly engineered kinetic energy converters ever deployed in a consumer machine. It absorbs violent mechanical force, the raw, explosive rotation of your engine, and transforms it into the electrical lifeblood of your vehicle. It commands the ignition. It powers the climate control. It pushes energy into the lithium cells in your pocket. Everything operates because this singular heavy piece of metal refuses to stop spinning. And when it finally fails to start your car, it has not failed mechanically. It has merely retired from that one specific, captive job. Consider the environment this machine was built to survive. Engine blocks are hostile territory. The alternator is designed to shrug off blistering radiant heat, relentless high-frequency vibration, and years of corrosive road grit. Inside its scarred aluminum shell lies a labyrinth of precision-wound copper, permanent magnets, high-tolerance steel bearings, and a solid-state rectifier built to hammer chaotic electrical waves into a smooth, usable baseline. You are taking a masterpiece of thermodynamic endurance and throwing it into the trash. It is a staggering waste. Let us examine the architecture of this mistake. On the exterior, it appears to be nothing but a dull, oxidized housing. But breach that casing, and you reveal the rotor. This is the spinning heart of the machine, tightly wrapped in miles of precision-wound copper wire. Enclosing this rotor is the stator, a fixed ring of equally dense copper coils that remains completely stationary. As external force drives the rotor to spin inside the stator, it violently drags a changing magnetic field across those fixed wires. This intersecting motion displaces electrons. It induces a current. This is the absolute baseline of electromagnetic induction. As the physicist Michael Faraday demonstrated in the 19th century, a fluctuating magnetic field is the inescapable bridge between physical motion and electrical power. This exact mechanical architecture is not unique to your vehicle. It is the identical physics operating inside the massive concrete containment walls of hydroelectric dams. It is the same geometry, spinning at the peak of 300-foot wind turbines in the North Sea. They all harvest kinetic energy through rotating magnetic fields. And you are holding a miniaturized, heavily armored iteration of that global infrastructure in your bare hands. The resistance to this reality is entirely predictable. The immediate argument against keeping it is one of limitation. The consensus states that an automotive alternator is useless outside a vehicle because it only produces 12 to 14 volts of power. In its captive state, this is factual. Your vehicle requires exactly 14 volts of direct current to safely replenish a lead-acid battery without boiling the internal electrolytes. But this output is not a physical limit of the machine. It is an artificial boundary. That boundary is enforced by the voltage regulator, a tiny semiconductor module acting as a strict governor. It chokes off the alternator's true capacity to protect the fragile electronics of a dashboard. Strip that regulator away. Spin that rotor at higher velocities, using an external force, and the raw electrical output scales violently upward. Faster rotation equates to higher voltage. Denser copper windings equate to immense current. This is not mechanical theory. It is unavoidable physics. Off-grid engineers and isolated hobbyists have exploited this bypass for decades. It remains a hidden science simply because no one explains the baseline mechanics in plain language. The secondary argument is always economic. You are instructed to carry this heavy block of metal back to the parts counter and surrender it for a core charge. They will hand you $20, perhaps $40. The unit will be shipped to a remanufacturing facility, tested, and sold back into the exact same captive ecosystem. It is a legitimate supply chain, but it is an asymmetrical trade. You are exchanging an industrial-grade power plant for a handful of paper currency. You are giving away a device that, with a rudimentary understanding of electromagnetism, could autonomously power a workshop, illuminate a remote structure, or isolate you from a fragile power grid. Do not make that trade blindly. If you refuse the trade, you must deploy the machine. The most historically proven application is atmospheric kinetic harvesting. Since the 1970s, isolated homesteaders across the Canadian Shield and the Australian outback have mounted these salvaged alternators atop steel towers. They bolt hand-carved wooden blades to the rotor shaft and surrender the machine to the wind. Air currents push against the blades, translating atmospheric pressure into rotational torque. The rotor spins. The magnetic field tears through the copper stator. Electricity floods down the tower into a chemical battery bank, where a solid-state inverter forces the raw DC voltage into standard household alternating current. Will it power a massive, modern, climate-controlled estate? No. It will keep a remote structure illuminated. It will preserve refrigerated food. It will keep your equipment running. Yet, critics remain paralyzed by the factory specifications. They argue the voltage is too weak to run standard appliances. They fail to understand the fundamental mechanics of modification. In its captive state, bolted to a commercial engine block, the alternator is artificially strangled. Remove the voltage regulator. Detach the unit from the vehicle's electrical limitations. Drive the rotor to higher revolutions per minute using a wind-driven turbine or an external motor, and the electrical ceiling shatters. By simply increasing rotational velocity, modified automotive alternators routinely produce well over 100 volts of raw alternating current. The 12-volt output was never a physical limit. It was a factory suggestion. Then, there is the outright manipulation of the magnetic field itself. A standard automotive alternator relies on a physical mechanism called field excitation. It requires a parasitic drip of electricity from the car's battery to energize the rotor's internal electromagnet before it can produce any power of its own. It is a dependent system. Off-grid engineers eliminate this dependency entirely. They extract the factory rotor and strip away the heavy electromagnetic coils. In their place, they epoxy rare earth neodymium magnets, the exact heavy-duty compounds used in commercial acoustic arrays, directly to the spinning shaft. By embedding permanent magnets, the machine no longer requires a starting current. It ceases to be an alternator and becomes a permanent magnet generator. The exact millisecond the shaft turns, electrons flow. No battery required. No external excitation. Just raw kinetic conversion. But this conversion demands absolute physical discipline. If a neodymium magnet is secured even a fraction of a millimeter off-center, the magnetic pull becomes asymmetrical. At 2,000 revolutions per minute, that microscopic imbalance translates into violent, high-frequency vibration. It will tear the internal steel bearings apart. It requires absolute precision, immense patience, and high-temperature silicone adhesives to achieve perfect rotational symmetry. The rotor must spin flawlessly. If wind is inconsistent, you look to fluid dynamics. A small creek or a consistent stream flowing across a property offers a massive mechanical advantage. As hydroengineers at the National Renewable Energy Laboratory have documented for decades, the energy density of moving water is roughly 800 times that of air. Its kinetic energy transfer is staggering. By directing a steady flow of water through a standard PVC pipe and forcing it to strike a simple paddle wheel bolted to the alternator shaft, you create a micro-hydroelectric plant. Wendy's. Sunlight fades. Water obeys gravity without interruption. It flows through the night, driving the heavy copper rotor relentlessly. Finally, there is the simplest mechanical marriage. Connecting the alternator to a small salvaged gasoline engine on a wooden workbench. Predictably, critics immediately cite the laws of physics. They argue that burning gasoline to spin a separate motor to drive an alternator is grossly inefficient compared to purchasing a commercially engineered portable generator. Mathematically, they are absolutely correct. The first law of thermodynamics dictates that energy cannot be created or destroyed, but every mechanical transfer incurs a heavy tax. Friction eats energy. Heat bleeds off efficiency. Entropy always wins. But the critics completely misunderstand the equation. If you already possess an abandoned alternator, and you already own a discarded push-mower engine, the financial capital required to build a backup power supply is effectively zero. You are not purchasing thermodynamic perfection. You are engineering immediate survival capability from discarded steel. It is a completely different calculation, and that calculation assessing the raw kinetic potential of the steel you already possess is the dividing line. We occupy a socio-economic architecture engineered explicitly for cyclical consumption. Every supply chain, every manufactured system around us is brutally optimized to force a single, repetitive human behavior. When the engine stutters, purchase a replacement. When the internal bearing begins to whine, discard the entire housing. When the current stops flowing, blindly upgrade to the newest model. We repeat this loop eternally because it is the path of absolute least resistance. We were never taught to gaze at a shattered object and run a mechanical diagnostic on its surviving components. We were trained to obey the system's final verdict of worthlessness. This is the silent, compounding debt the system demands. The narrative of the alternator is not truly about automotive parts. It is the strict practice of imposing a calculated pause before surrendering complex matter to the landfill. The individual who understands how raw energy is channeled, how dense copper displaces electrons, and how thermodynamic laws interact with everyday objects is never truly subjected to grid failure. Tools inevitably fracture. Knowledge relentlessly compounds. The individual who commands physics holds infinite options. Let us translate theory into strict physical action. If you possess an alternator salvaged from a scrapyard for a handful of coins, the process begins with absolute technical identification. Do not guess. Look at the alphanumeric sequence stamped into the oxidized casing. Not all internal stators are wound equally. Some units integrate complex digital regulators that require surgical bypasses. Some contain architectures perfectly matched for neodymium magnet insertion. A precise audit of the model number will connect you directly to the blueprints of off-grid engineers. These digital communities have already mapped the exact electrical breaking points of these machines. They have burned out the stators. They have shattered the bearings. They have done the empirical math. Rely on their schematics. Stand on their shoulders. Next, evaluate your environmental assets through the lens of physics. Do you live in a valley flooded with uninterrupted wind? Do you have access to continuous fluid dynamics through a stream carving through your property? Or do you merely have a small internal combustion engine sitting idle, capable of providing backup illumination during a blackout? The laws of physics dictating your environment must entirely dictate your mechanical build. There is no universal schematic. There is only the ruthless application of what you have to what you need. Start slowly. You do not need to engineer an off-grid compound in a single afternoon. Begin by bolting the unit to a steel bench. Drive the rotor shaft with a standard power drill, place a multimeter across its output terminals, and measure the raw alternating current. Watching those numbers climb on a digital screen is a profound kinetic reality. It will teach you more about electromagnetic induction in 20 minutes than a lifetime of paying residential utility bills. Prove the physics yourself. Skepticism is a mandatory requirement in any scientific pursuit. Question exaggerated voltage claims. Push back violently against impossible mathematical efficiencies. Demand empirical proof when the rotational math does not align with the claimed wattage. Healthy skepticism protects you from thermodynamic impossibilities. But recognize the exact moment when healthy skepticism decays into intellectual paralysis. When your default response to mechanical modification is immediate dismissal, you permanently seal off your own capacity to build. You close the door on any reality that violates your captive understanding. The engineers who first fused hand-carved wooden blades to automotive stators were dismissed as fools. The pioneers who submerged raw copper windings into freezing mountain streams were told the thermodynamics would never balance. They were instructed to simply stop fighting the modern supply chain. Most people obeyed. They paid the core charge. They traded their independence for convenience. But a fraction of them remained in the garage. They cracked the aluminum housing open. They aligned the magnetic fields, manipulated the copper, and manufactured their own electrical independence. They built working power grids from garbage. Here is your physical imperative. Walk into your garage today. Locate the heaviest, most oxidized piece of discarded machinery you were preparing to throw away. Place it squarely on your workbench. Put a multimeter across its terminals, attach a wrench to the main shaft, and manually force the metal to rotate. Give yourself exactly 7 days to map its physical tolerances and measure its true output before you condemn it to the scrap heap. The only difference between industrial waste and infinite kinetic potential is your willingness to dictate the mechanics. At precisely 1,000 revolutions per minute, that supposedly dead block of aluminum will still violently strip electrons from the fabric of reality. The machine is not dead. You just stopped spinning it,